Hey guys, it is week 11. We only have 2 more weeks after this. I'm sorry that I am not here for a live class. This video recording will have to do. But I wanted to talk to you guys today about mixtures, okay? So if you remember last week, we were talking about reactions, chemical reactions. So do you guys remember elephant toothpaste? And then also we made these crystals, these sugar crystals. Okay, so one of these is an example of a chemical reaction, and one of these is a physical reaction. So a chemical reaction is when you have two things, you put it together, and it forms something completely new on a molecular level. The other does not change on a molecular level. It still has the same characteristics. So which one do you think is a chemical reaction? Do you think it's elephant toothpaste or the sugar crystals? And which one do you think is a physical reaction? So if you guessed elephant toothpaste as the chemical reaction, you are correct. There's been a change, a complete change in what has been formed. Unlike with the sugar crystals, it's just a new state in how it's just gathered together and formed the sugar crystals along the wooden sticks. So we are going to talk today about mixtures. Now mixtures are different. They're not chemical reactions, they are physical reactions. It's just mixing two or more things together and it creates something, but it's not completely new on a molecular level, okay? It might look different, but it has not changed on a molecular level. So each substance keeps its chemical identity and its original properties stay the same. So there are lots of mixtures out there, and some you can tell are mixtures. So here we can see salsa, and we see that it's a mixture of a lot of different things. We have tomatoes, onions, peppers, cilantro. Over here we have macaroni and cheese. You can see the noodles and the cheese. And so when there is a mixture that we can tell what it is, we call that heterogeneous. Okay, so that means hetero is from Greek. It means different, and we can see that there are differences within this. But there are some things out there that look the same. It looks like it's one thing, like milk. So you might think when you drink milk, you're only drinking milk. But milk is made up of so many different things like water, fats, proteins. Okay, so you can't tell as easily that this is a mixture. And so these are called homogeneous mixtures. That means homo means the same. It looks like it's the same, but it's not, okay? So this is a homogeneous mixture. All right, so I want you to think about this. Do you think this is a heterogeneous mixture or a homogeneous mixture? We have a milkshake, okay? So think about this. I'll come back. We have sugar cubes. We have a chocolate chip cookie, toothpaste, cereal, hot dogs, and some gravel, some dirt. Okay, so what do you think? I want you to be thinking about this in your head. Okay, so with a milkshake, it looks like it's one thing, unless, if you had chocolate chips in there or different like candies in there and you could see it, it would be heterogeneous, but it's a homogeneous here in this picture. This sugar cube, it looks like it's one thing, though it is not. So this is a homogeneous mixture. With the chocolate chip cookie, we can see that there's dough and chocolate chips. So that is pretty easy. That is heterogeneous mixture. And then we have for the cookie. And we have toothpaste over here. It looks like it's one thing. So that is a homogeneous mixture. Here we have cereal and milk, so that is a heterogeneous mixture. And then hot dogs, it looks like it's one thing, though it's many different things put together, and that is a homogeneous mixture. And dirt, over here we can see different pebbles and and lots of different things in there. And so that is a heterogeneous mixture. Okay, so I want you to remember, if it's homogeneous, it means that it looks like it's one thing, but it's a couple things mixed together. If it's heterogeneous, it is two or more things mixed together, and you can tell just by looking at it that it is a mixture. So I'm curious, have you ever gone to a pond and seen something like this? So this is pond scum. Okay, so it's floating on the top. So what do you think this is? Do you think this is a heterogeneous mixture or a homogeneous mixture? So remember what that means. So homogeneous means it looks like one thing. Heterogeneous means that you can tell that there's a difference, that there's more than one thing. So if you guessed heterogeneous mixture, then you are right. And when we have something like this where it's floating on the top, it is called a suspension. Okay, so a suspension is like larger particles that are mixed with smaller particles. And over time, eventually they separate, and that's why they're called a suspension. And they will either float or they will sink. So when we made lava lamps in our lab that one week, that was a suspension. Another suspension would be like opening a can of soda. You open it and you hear that air come out, that carbon dioxide comes out, and that is a suspension. It separates. Okay, so there are some things though that are solutions. So with solutions, now they're different than suspensions. With suspensions, it's larger particles that's mixed with smaller particles. With solutions though, you can't tell, it's all mixed in there equally, and you can't see that there's a difference. You can't see something floating in here. It looks like one thing, and that's sort of like saline solution, like in this picture. It looks like it's one thing, but it's a mixture. All solutions, they either have what is called a solute, and that's something that's being dissolved, and there's the solvent, and that is what is doing the dissolving. Okay, so we have a solute, it's being dissolved, and the solvent is doing the dissolving. Okay, and we'll go more into that. So what I want you to think about is the ocean. I love going to the ocean. And with this, in the ocean, it is not just ocean water. There are many different things in there. But what I want you to focus on is that salt water is made up of water and salt. What is doing the dissolving is the water. So that is called the solvent. What is being dissolved is the salt. So that is the solute. Okay? So one thing that's really important for you to know is that water, regular water, so H2O, so you know what that means. We have covered that. H2O is known as a universal solvent. And this is super important because a universal solvent means that many things can go into it and dissolve. Okay, so water, it's generally neutral. You know, we've talked about positive and negative charges. Water is generally neutral. But something that's interesting about water is that there is a slight positive charge and a slight negative charge. Okay, so when you put something in the water that is positively charged, it's gonna bind to the negative charge of the oxygen. Or if you put something in that's negatively charged, it's gonna bind to the hydrogen. Okay, because one is slightly negative and the other is slightly positive. Now when anything bonds with it, that's what makes it where it's able to break up and to dissolve. And so that is why water is so special. It is a universal solvent. It's able to have lots of things dissolve in it because it has a slight negative and a slight positive charge. We have what is called a colloid. Okay, colloids are larger than particles in the solution, but they're smaller than suspensions. Remember, suspensions are pretty big and they're mixed with smaller things. Well, the colloids are smaller than the suspensions, but they're bigger than what's in solution. So if we were to have, if we milked a cow, okay, and we looked at the milk in the pail, we would notice that there would be water on the bottom, okay, and fat globules at the top. So there would be a separation there. And before milk is sold at the stores, it is mixed up so well. It's homogenized. That means mixed up really, really well, so it looks like it's one thing before it's sold. But if we were to take this milk and look under a microscope, we would be able to see the fat globules, whereas with the solution, we wouldn't be able to see that because it's all evenly distributed, and you can't even notice that it's a mixture. With a colloid, you can do that with a microscope. With a suspension, you can do it just by looking at it. Okay, so suspensions are big, colloids are they're smaller, and solutions, they're even smaller, okay, when we're talking about things that they're mixed with. All right, so here's some examples of colloids. We have gels. That's like a solid and a liquid mixed together, and you get a gel. You can have like hairspray. It's a liquid and a gas. We also have whipped cream. That's a liquid and a gas. Or just paints. You can have liquid and a liquid mixed together. So how can we separate things? When we have all these mixtures and we want to know how do we separate them? One, we can evaporate. That's one thing that you can do. So with salts, you can evaporate the water and see what's left over. Okay, so that's evaporation. Filtration is when you pass the substance through some material and it's able to trap particles. Okay, so we all have filters in our air conditioner. It traps the dust and the nastiness that's in our air in our house. Okay, then there's also sifting. So with sifting, you're able to separate larger particles from smaller particles by putting it through, do you see this mesh colander? Okay, so that's sifting. And then magnetism, so if there's something that is able to be attracted to a magnet, you can use one big magnet and be able to separate it from things that are not magnetic. Okay, and then we have chromography. So chromography separates mixtures as they move across a particular material that attracts the components differently. So with this, when you do the lab this week, we are going to be working on chromography. So that's one thing that we will do. We're also going to be dealing with colloids. So you'll be able to see a colloid, which is also going to be a homogeneous mixture. All right, so make sure that you do your lab. And as I always say, if you have any questions, have your parent reach out to me. I am sorry that I am not here this week. I am having my teeth worked on, and so I knew I wouldn't be able to talk that well. So I decided to go ahead and record this for you. But if you have any questions, have your parents reach out to me. I will answer them. And then I will see you next week on Tuesday. Until then, happy learning.